When you see lightning, it's incredibly powerful. But what if you could see the invisible electrical activity building up before the big flash, maybe even before a tornado forms?
That's really the core idea we're exploring today. We're looking at the Geostationary Lightning Mapper, the GLM.
Right.
And for you, the listener who's intellectually curious, wants to grasp new science quickly, our mission here is to show how this one instrument, well, it's doing more than just watching lightning. It's changing the game for severe storm forecasting, giving us this unprecedented look inside a storm's electrical life.
It really is state-of-the-art stuff. It's like suddenly having a constant pulse check on the atmosphere's electrical health, where before we were kind of, feeling around in the dark a bit.
Exactly. Before GLM, getting continuous high-res data on the electrosphere, that's the electrical environment around Earth, was frankly incredibly difficult.
Yeah.
GLM provides that data stream, filling gaps we used to have.
Gaps from just relying on ground sensors or satellites passing over now and then.
Precisely. Sporadic data points versus a continuous movie, essentially.
Okay, this deep dive is brought to you by embersilk.com. Embersilk is the answer for all your AI education and integration needs. So let's get down to the basics then. GLM, what exactly is it, and where does it live?
Okay, so GLM is an instrument carried on a satellite. Specifically, it's on the GOES-16 satellite. It went up in late 2016, started its operational work around March 2017.
And technically speaking?
Technically, it's a single-channel near-infrared optical transient detector.
Okay, that's a bit technical. Can you break that down? Is it like a super specialized camera?
That's a good way to put it, yeah. Think of it as a very fast, very sensitive camera tuned to see just the specific burst of near-infrared light that lightning gives off, even tiny flashes.
And the geostationary part of the name is obviously important. It's way up there, about 36,000 kilometers. Why does that orbit matter so much for tracking lightning?
Well, because geostationary means it orbits at the same speed the Earth rotates.
So it stays over the same spot?
Essentially, yes. It hovers over a fixed region covering the U.S., parts of the oceans nearby. Unlike satellites that zip around the poles, GLM gives us this continuous 247 view.
Right, no gaps in coverage for its area.
Exactly.
Yeah.
And that allows for detecting total lightning all types at a rate we just couldn't get from space before.
Total lightning, that's the key, isn't it? Older systems, ground-based ones, they mostly caught the big cloud-to-ground strikes, right?
Oh.
What's GLM seeing that's, well, more valuable for forecasting?
It sees all of it, day-night, continuously. But the really crucial bit is its ability to see the intra-cloud lightning.
The flashes inside the cloud.
Yes, those flashes happening entirely within the cloud structure. And, that internal electrical activity often ramps up significantly before the first ground strike, sometimes 10, even 20 minutes before the worst weather hits.
So it's like an early warning sign from inside the storm itself.
Precisely. We're shifting from reacting to severe weather to actually predicting its intensification much earlier.
And you mentioned flash rate. That's the connection. Seeing more flashes inside means the storm's getting nasty.
That's the core finding, yes. A sudden, rapid increase in the total flash rate, mostly that in-cloud stuff, is directly linked to how severe the storm is becoming. It tells us about the updrafts, how intense the rain or hail might be, even the potential for tornadoes.
Okay. And the specs help here. You mentioned high resolution.
Right. It has good spatial resolution, around 10 kilometers, which is pretty decent from that altitude. But the temporal resolution is amazing. It updates its view every 20 seconds.
Wow, every 20 seconds. That's incredibly fast for watching weather develop.
It is. It means we catch those really brief flashes, and we see that rate ramp up almost in real time. Now, 10 kilometers might sound a bit broad for pinpointing, say, a tornado exactly. But when forecasters combine that flash rate jump with radar data, satellite cloud images, and other info, that's where you get that critical extra lead time for warnings.
Makes sense. So beyond the immediate warnings, what about the bigger scientific picture?
Well, scientists can now study the whole electrosphere in a way they couldn't before. From the scale of the entire planet down to individual storm cells. It's like mapping the Earth's electrical circuits.
A complete electrical map.
But, and this is maybe the most important takeaway, the real power isn't just the GLM data sitting by itself.
Oh, so what unlocks its full potential then?
It's the integration. You have to take the raw GLM data, which comes as detections we call events, groups, and flashes, and weave it together with everything else we can see.
Like radar.
Exactly. Radar returns, cloud pictures from other GOES instruments, temperature data, wind fields. All those meteorological variables.
Okay, just quickly, you said events, groups, flashes. What's the difference there for someone trying to understand that data?
Right. Good question. So an event is basically one pixel lighting up on the detector. A group is a few adjacent pixels lighting up at the same moment. And a flash is kind of the whole lightning discharge made up of several groups happening over a very short time, maybe spread out a bit.
So event is the spark, group is a cluster of sparks, flash is the whole firework.
That's a pretty good analogy, yeah. We're looking at the whole chain reaction the flash built from those smaller pieces. And seeing how all that data fits together, that integrated view, that's what really pushes modern storm prediction forward.
So the GLM is this amazing eye in the sky, giving us a continuous integrated picture of the storm's electrical engine, a real step change in early warnings.
Absolutely.
Well, this has been fascinating. We really appreciate you taking this deep dive with us today. And for you listening, if you found this valuable, please do subscribe and maybe leave us a 5-star review. It genuinely helps get these discussions out there.
And thank you again to our sponsor, embersilk.com, for their support.